Now we are going to discuss data sufficiency question type. In this question type, the question will be given with two statements. You need to decide which statement is sufficient to say the answer. Here, give the answer choice like, if the statement 1 alone sufficient, mark the answer A. If we say first statement alone sufficient, that means second statement is not sufficient. Okay, next read the second statement. If the second statement alone sufficient, answer is B. If the first statement alone not sufficient and second statement alone not sufficient, then combine these two statements. If we get the answer, then mark the answer as option as C. Next, if the statement 1 alone sufficient or statement 2 alone sufficient, mark the answer as D. If both the statements together are still not sufficient, the answer is E. You need to remember two question types. The first question type is WH. The one is WH. The other question type is yes or no. For this question type, you need to remember the word unique. For this question type, you need to remember the word definite. These two are very important. While reading the question itself, you can understand which type the question is. Okay. First, consider the first question. What's the value of x? Read the first statement. X plus y is equal to 5. It's a WH question, right? WH type. Can you find out the unique value of x? No. First statement alone not sufficient. The reason is 2 plus 3 is equal to 5, or 3 plus 2 is equal to 5, 1 plus 4 is equal to 5, 4 plus 1 is equal to 5. Now we can't say unique value of x. That's why the first statement is not sufficient. Read the second statement alone. X minus y equal to 3. Is it sufficient to say the value of x? No. The reason is 5 minus 2 is equal to 3, or 7 minus 4 is equal to 3. We have many possibilities. So second statement alone not sufficient. Combine these two statements. X plus y is equal to 5. X minus y equal to 3. Can you find out the value of x? Yes. Two equations. Two unknowns. Here that's a simple equation. You can find out the answer for value of x. So the answer for this question is C. That means together only sufficient. Next, we are going to discuss yes or no type. Is x greater than y? Read the first statement. X plus y is equal to 5. The first statement is not sufficient to say the definite answer. Read the second one. X minus y equal to 3. We can say x minus y is equal to positive. Means x is greater than, here in this case x is greater than y. So second statement alone sufficient to say definite yes. So the answer is B. Only two types. The first one is WH type. The second one is yes or no type. The question is, what's the value of x power 200? This is WH type. Here no need to find out x power 200 value. What we need to find out, which statement is sufficient to say the value of x. That means unique value of x. Here x is a prime number. X is a prime means x takes values 2, 3, 5, 7, ... Can you find out the unique value of x using the first statement? No. First statement is not sufficient to say the unique value of x. Read the second statement alone. X is an even number. X is an even number means x takes the values 2, 4, 6, 8, ... Can you see the unique value of x using the second statement? Second statement also not sufficient to say the unique value of x. Now combine these two statements together. X is a prime number, x is an even number. Okay, here we know only one even prime number, 2. After combining these two statements, can you get the unique value of x? Yes, you can get the unique value of x. The question is x greater than y? First statement says x square greater than y square. Second statement, x is equal to y. Take the first statement, x square greater than y square, right? Here, simple example, if I choose x square equal to 9 and y square equal to 4, x square is greater than y square. What's the question? Is x greater than y? See, in this case, if I choose x square equal to 9, x value is plus or minus 3. Here, y square equal to 4, y value is plus or minus 2, right? So, plus 3, if I choose plus 3 plus 2, x value plus 3 and y value plus 2, in that case also, x square is greater than y square. The second one, if I take minus 3 and plus 2, in this case also x square is greater than y square. Next one, plus 3 minus 2, in this case also x square is greater than y square. Next one, minus 3 minus 2, here also x square is greater than y square. But the comparison, what's the question? In the question, is x greater than y? In the first case, is x greater than y? Yes. In the second case, is x greater than y? No. Third case, is x greater than y? Yes. In the fourth case, is x greater than y? No. Sometimes yes, sometimes no. First statement is not sufficient to say definite answer. Read the second statement. It's a good statement. X is equal to y. What's the question? Is x greater than y? Immediately you can say no, x is not greater than y, x is equal to y. To say definite no, second statement is sufficient. Answer choice for this question is answer choice B. Second statement alone sufficient to say definite no. So the answer for this question is answer choice B. The question says, is the integer n divisible by 9? N is a 2-digit number. Listen, this one is yes or no type question. Okay. First statement, when n is divided by 3, the remainder is 2. Second statement, when n is divided by 7, the remainder is 1. Take the first statement. When n is divided by 3, the remainder is 2. Okay. No need to find out the value of n. Here, question is whether n is divisible by 9 or not. See, n when divided by 3, the remainder is 2. That means n is not divisible by 3. A number is not divisible by 3 means we can understand clearly it cannot be divisible by 9 also. So is the integer n divisible by 9? Using the first statement you can say definite no. To say definite no, first statement is sufficient. Next, read the second statement alone. When n divided by 7, the remainder is 1. Take one example. If I take 36 divided by 7, the remainder is 1. Right? Okay. When divided by 7, the remainder is 1. Here, we need to check whether 36 is divisible by 9 or not. In this case, yes. 36 divided by 7, the remainder is 1. 36 also divisible by 9. Next, I will take one more case. The remainder 50 divided by 7. 50 divided by 7, the remainder is 1. Okay, my question is, I need to check whether 50 is divisible by 9 or not. 50 is not divisible by 9. In this case, the answer is no. Okay, sometimes yes, sometimes no. Second statement is not sufficient to say definite yes or definite no. So second statement is not sufficient. So answer for this question, option choice is A. First statement is alone sufficient. What is the angle of x? It's a triangle, it's given. Okay. First statement, x plus y is equal to 136 degree. The second statement, z plus y is equal to 153 degree. Here you need to remember one thing. Sum of the interior angles of a triangle is 180 degree. X plus y plus z is equal to 180 degree. That's a universal truth. Read the first statement. X plus y is equal to 136 degree. Can we find out the x value using the first statement? No, it is not sufficient to find out the value of x. Read the second statement. Z plus y is equal to 153. Once we know z plus y equal to 153 degree, can we find out the value of x? Yes. Using the second statement, we can find out the value of x. Second statement alone sufficient. Answer for option for this question is answer choice B. What will be the remainder when 34 power n is divided by 7? First statement, n is an odd number. The second statement, n is an even number. Listen here, 34 divided by 7, what will be the remainder? The remainder is 6, right? If I take 34 power 3 divided by 7 is equal to remainder of 6 power 3 divided by 7. Okay, 34 power 3 divided by 7 is equal to 6 power 3 divided by 7. The reason is, once we say 34 power n divided by 7 is equal to remainder of 6 power n divided by 7, both are same. The reason is, initial remainder when 34 is divided by 7 is 6. Okay, 6 power 3 divided by 7, the remainder is 6. Next, remainder 6 power 5 divided by 7, also the remainder is 6. 6 power 7 divided by 7, the remainder is 6. If 6 power odd number divided by 7, always the remainder is 6. So what will be the remainder when 34 power n is divided by 7? If n is odd number, we get the unique remainder 6. Okay, forget about the first statement. Read the second statement. N is an even number. Second statement, we take n is an even number. The second statement, right? We can use the same logic. 34 power 2 divided by 7 is equal to remainder 6 square divided by 7. What's the remainder? The remainder is 1. Next one, remainder 6 power 4, or we can say 34 power 4 divided by 7. What's the remainder? Remainder again 1. Remainder 6 power 6 divided by 7 is equal to 1. From this clearly we can understand, if n is even, 34 power n divided by 7, always the remainder is 1. We get only the unique value, right? So n is an even number. If n is even number, we get unique value, right? 1. Okay, what's the answer choice for this one? First statement alone sufficient to say the unique value, unique remainder. The second statement also sufficient to find the unique remainder. Answer choice for this question is answer choice D. What's the HCF of a number? The first statement, the product of LCM and HCF of two numbers is 10,800. Second one of the numbers is 90. Listen, you need to remember one concept. LCM into HCF is equal to product of two numbers. Say A into B. Product of two numbers is equal to LCM of two numbers into HCF of two numbers. Here LCM into HCF is equal to, it is given 10800. Using the first statement, can we find out the HCF of the number? No, it is not possible, right? Okay, take the second statement. One of the numbers is 90. Using the second statement alone, can we find out the HCF? Okay, no, it is not possible. The reason is, one of the numbers we know 90, the other number we don't know, right? Okay, if we combine these two statements, once we combine these two statements, A into B equal to 10800. One of the numbers A is 90. If A equal to 90, then B should be 120, right? Once we know A value and B value, can we find out the HCF value? Yes. So answer for this question is C. Combine these two statements. is sufficient. Who is the best worker among A, B and C? Read the first statement. A and B can complete the work in 20 days. That means the normal method we say 1 by A plus 1 by B equal to 1 by 20. Can you find out who is the best worker among A, B, C? First statement is not sufficient. Read the second statement alone. 1 by B plus 1 by C is equal to 1 by 15. The rate of work of B and C is 1 by 15. The question is who is the best worker among A, B, C? Second statement alone, it's not sufficient. Okay, now combine these two statements. Even if you combine these two statements, you won't get who is the best worker among A, B, C. The reason is you need one more information to find out who is the best worker. So the answer for this question is answer choice E. What's the value of x? First statement, x square minus 5x plus 6 equal to 0. Second statement, x is greater than 2. First statement, x square minus 5x plus 6 equal to 0 means we get two values, x equal to 2 and x equal to 3. Two values we get, right, after factorizing this. Is it sufficient? The word unique you need to remember. It's not sufficient. Okay, first statement is not sufficient to say the unique value of x. Read the second statement alone. Please try to understand. Read the second statement alone. The x value is greater than 2. X value greater than 2 means 2.1, 2.2, 2.3, 2.4, right? Even integer or fraction also possible, right? Okay. Using the second statement alone, can you find out the value of x? Second statement alone is not sufficient. Now combine these two statements. X square minus 5x plus 6 equal to 0 and x is greater than 2. That means the value of x is not 2. X should be greater than 2. It is given. So the value of x should be 3. After combining these two statements, we can say the unique value of x is 3. So the answer choice is answer choice C. What's the value of the two-digit number n? The first statement says the sum of the two digits is 6. The second statement says the difference between the digits is 2. Take the first statement. Sum of the two digits is 6. For example, 15. Sum of the two digits is 6. Then 24, 33, 42, 51. Sum of the two digits is 6. Here, what's the value of the two-digit number? We need to remember the word unique. Two-digit number, many possibilities are there. We don't get the unique value of a two-digit number. So first statement is not sufficient. Read the second statement. Difference between the digits is 2. Example, 1 3 or 3 1 or 2 4 or 4 2, 5 3 or 3 5. Using the second statement, can you get unique value of a two-digit number? No. Second statement alone not sufficient. Now combine these two statements. Sum of the digits is 6, difference of the digits is 2. Okay, here if I take like this, here 24, sum of the digits is 6, difference is 2, right? 42 also, sum of the digits is 6, difference is 2, right? Here 24 and 42. After combining these two statements, we are getting 24 and 42. Is it sufficient? No. The reason is we don't get unique value of a two-digit number. So even if you combine these two statements, it is not sufficient to say the unique value of a two-digit number. So the answer for this question is answer choice E. What's average of P, Q and R? Is the statement says 2P plus Q plus 4R equal to 43. The next one, 3P plus R plus 4Q is equal to 42. Read the first statement. 2P plus Q plus 4R equal to 43. Can you find the average of P, Q and R? No, first statement is not sufficient to find out. Read the second statement. 3P plus R plus 4Q is equal to 42. Is it sufficient to find out the average of P, Q and R? No. First statement alone not sufficient. Second statement alone not sufficient. What we need to do? We need to combine. We need to check whether it gives the answer or not. 2p plus q plus 4 are equal to 43. The next one 3p plus 4q plus r is equal to 42. If you add these two, we get 5p plus 5q plus 5r equal to 85, right? So take 5 outside, p plus q plus r equal to 85. See, once we know p plus q plus r value, can you find out the r of these three values? Yes. So if you combine these two statements, only sufficient. Answer for this question is answer choice C. Given that x and y are real numbers, what's the value of x plus y? First statement, x square minus y square divided by x minus y equal to 8. Second statement, x plus y whole square equal to 64. Take the first statement. First statement can be written as x plus y into x minus y divided by x minus y is equal to 8. Can we get x plus y value? Yes, using the first statement we can get the x plus y value. The reason is x minus y gets cancelled, so we can get using the first statement. Okay, read the second statement. X plus y whole square equal to 64. X plus y whole square equal to 64. What's the value of x plus y? X plus y equal to plus or minus 8. Here you need to remember a word, unique. X plus y equal to plus 8 or minus 8. X plus y equal to 8 or x plus y equal to minus 8. Okay. Using the second statement, you can't find out the unique value of x plus y. So second statement is not sufficient. So the answer choice for this question is A. What's the value of x square plus 1 by x square? The first statement says x plus 1 by x is equal to 5. Second statement, x minus 1 by x is equal to 3. Okay, take the first statement, x plus 1 by x is equal to 5. Can we get the value of x square plus 1 by x square from this? Here, if you square both the sides, x plus 1 by x whole square is equal to 5 square, right? This is in the form of a plus b whole square. So a square plus b square plus 2 into ab is equal to 25. Here we can get here x square plus 1 by x square, x gets cancelled. So 25 minus 2, 23. Using the first statement, yes, first statement alone sufficient. Read the second statement, x minus 1 by x is equal to 3. Square both the sides, x minus 1 by x whole square is equal to 9. So x square plus 1 by x square minus 2 into x into 1 by x is equal to 9. X gets cancelled, x square plus 1 by x square equal to 11. Using the second statement, can we find out the answer? Yes. So here first statement alone sufficient to find out the answer. Second statement alone sufficient to find out the answer. So answer for this question is answer is D. Is x an integer? The first statement 7x an integer. The second statement 6x is a fraction. Listen here, this is yes or no type. 7 into x, it's a given integer. Don't change the condition. 7 into, if I substitute 7 into 1, yes, integer. 7 into 2, integer. 7 into 3, yes, 7 into 3 also integer. Okay, fine. 7 into 1 by 7, integer. Yes. 7 into 2 by 7 is integer. Yes, fine. Listen here. Question, what's the question? Is x an integer? X integer. Here integer, here also integer, here also integer. What about this one? No, x is not an integer. Here integer. 7 into x an integer means sometimes x is integer, sometimes x is not integer. The question is x an integer? In this case you can say yes. In this case you can say yes. In this case you can say yes. In this case you need to say no. In this case you need to say no. So sometimes yes, sometimes no. First statement is not sufficient to say the definite answer. So first statement is not sufficient. Read the second statement. 6 into x fraction, 6 into x fraction, right? 6 into 0.1, it's a fraction, right? 6 into 0.2, it's a fraction, right? Okay, 6 into 0.3, yes. Okay, you cannot substitute here integer. The reason is 6 into integer cannot give you the fraction. 6 into x fraction means x should be fraction. What's the question? Is x an integer? You can say definite no. X is a fraction means x should be fraction. What's the question? Is x an integer? You can say definite no using the second statement. So the answer for the question is answer choice B. That's a very good question. Question is x an even number? The statement 1, 3 into x is an even number. Statement 2 into x an even number. Okay, here this one is yes or no type. You need to say either definite yes or definite no. 3x is an even number. 3 into x, 3 into x even, right? Okay, if I substitute x equal to 1, 3 into 1 is equal to 3, but we don't get even number, right? So 3 into 2, 3 into 2 even number, right? Okay, 3 into 2, then 3 into 4, then 3 into 6, okay, even number. Okay, 3 into even, so we can understand 3 into even only the even number, right? So 3 into x and even number means x should be even number. You can say definite yes using the first statement. Okay, read the second statement. 2 into x even number. If I substitute x equal to 1, 2 into 1 even, 2 into 2, 2 into 2 even, 2 into 3, 2 into 3 even. See here x is odd number, x is even number, x is odd number, even 2 into 4 even. Okay, sometimes odd number, sometimes even number. Question is x an even number? Using the second statement, can you say definite answer? No, second statement is not sufficient to say definite yes or definite no. So the answer for this question is option choice A. First statement alone sufficient to say definite yes. Question is x divisible by 6? Here this question is yes or no type. Okay, for this the word definite is important. Okay, you have to say definite yes or definite no. Which statement is sufficient to say definite yes or definite no? Okay, read the first statement. X is divisible by 8. X is divisible by 8. For example, 8, 16, 24, 32, 40. Here very important is yes or no type, right? We have to say definite yes or definite no. Okay, take the first statement. X values 8, 16, 24, 32, 40. Listen here. Here if I take 8, x as 8, is it divisible by 6? No. If I take x is 16, is it divisible by 6? No. If I take 24, yes, it's divisible by 6. If I take 32, no. If I take 40, no. So from this, can you answer is x is divisible by 6? Sometimes no, sometimes yes. First statement alone not sufficient. Next, read x is divisible by 3. Okay, second statement. Second statement says x is divisible by 3. 3, 6, 9, 12, 15. Okay, now we need to check whether it is divisible by 6 or not. 3, if I take 3, no. If I take 6, yes. If I take 9, no. If I take 12, yes. If I take 15, no. Here, is it sufficient to say the answer? No. The reason is we don't get the definite yes or definite no. No, yes, no, yes. Okay, second statement alone is not sufficient. Okay, what we need to do? Combine these two statements. X is divisible by 8, x is divisible by 3, right? First example is 24. Next one is 48. Next one is 72. Next one is 96. Okay, in this, if now we combine these two statements 1 and 2 together, first value 24, yes. Is it divisible by 6? 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 Yes. See, in all the cases it is divisible by 6, so we can say definite yes. Is x divisible by 6? Yes. Using two statements together, answer for this question is C. Question is, what's the value of x plus y? Read the first statement, x minus y is equal to 7. Second statement, 3x plus 3y is equal to 5. Here the question is, type is WH, right? Okay, x minus y is equal to 7. Can you find out the value of x plus y using the first statement? No. Read the second statement, 3x plus 3y is equal to 5. Can you find out the x plus y value using the second statement? Listen. Yes, you can find out the answer. Take 3 outside, x plus y is equal to 5, right? What's x plus y? X plus y equal to 5 by 3. It's possible to find out the value of x plus y using the second statement alone. Option for this question is B. No need to solve like this. For the explanation only, I solved. What's the value of x? First statement, x plus 2y equal to 5. Second statement, 2.5x plus 5y is equal to 7.5. Here the question is WH type, right? Okay, x plus 2y equal to 5. Can you find out the value of unique value of x? No. Second one, 2.5x plus 5y equal to 7.5. Can you find out the unique value of x? No. Now what you need to do? First statement alone not sufficient, second statement alone not sufficient, right? Now combine these two statements. X plus 2y is equal to 5, 2.5x plus 5y equal to 7.5. Please don't make mistake here. Here these two equations are same equation. Once you multiply by 2.5, you get the second equation. First equation into 2.5, you get second equation, right? So using these two statements together also, you can't find out the answer. The answer for this question is E.